this next interview, I want to bring on Harry, who's the co-founder of Gensyn, and we're going to talk about all things that they're doing, how do we actually decentralize compute, and the opportunity here that lies with crypto and AI. So please join me in welcoming Harry on stage, and we'll go right into the next chat. So this is a topic that is increasingly getting more and more requested for all of our events, and it's natural because as somebody who's kind of doing computer science, this is like the most obvious and timely overlap that they see. So our goal here is to kind of think about how do we perfectly blend and think about the opportunity with crypto and AI. But the thing I want to do is start off with maybe getting a bit more introduction on yourself and Gensyn. So what is it that you're working on and how does it work? And we'll kind of start with that.
Awesome, cheers. So Gensyn is a peer-to-peer machine learning compute protocol. In essence, it allows machine learning engineers, researchers, and also other machines, so artificially intelligent agents, to train neural networks. And it allows them to do this at extremely high scale, so basically internet scale, but also at a lower kind of unit economic cost than if you were to use, say, AWS, or even some of the custom GPU clouds. It came out of my co-founder and I, Dr. Ben Fielding, meeting in 2020 and kind of having this issue to, in our respective career trajectories where I was leading a machine learning research team at an applied AI startup here in London. We were predicting disaster events for insurance companies, and the cost of compute that we were incurring was marching ever upwards. And it was becoming quite clear, it was around the time that GPT-2 was released, but we thought there was going to be a kind of explosion.
GPT-2?
GPT-2, yeah.
Okay.
So GPT-2, I think it was early 2019. It became clear that, these models were generalizing. And I looked at it and I thought, okay, our compute costs are going up, these models are getting bigger, there needs to be a larger system to accommodate this. We are getting squeezed on price. This doesn't look good for the world. So that was my kind of run up to it. My co-founder, Ben, he was in academia, so he was doing a PhD in neural architecture design. And he basically had to build new neural architectures which would compete with labs like DeepMind, OpenAI, etc. But he had to do it with 4 GPUs under his desk in a university research lab. And it was basically impossible because Google had TPU clusters, he had all this stuff. He couldn't compete. We met each other in early 2020 and we kind of bonded over 2 things. We bonded over this kind of pretty stark economic problem which was emerging. But we also bonded over, funnily enough, Edward Snowden's autobiography, which had just come out, and this idea around there being increasing capture around a lot of the internet. And we thought, these models are getting more generalized, the prices are going up, and there's lots of oligopolists emerging. We need a solution to that. And that was the origin point.
Awesome. Well, so what does it mean for it to be internet scale, and you obviously talked about margins, which I want to get into a little bit later, but what is the scale that we're talking about here? Of course, we're seeing fights over GPU resources. You still can't buy off-the-shelf NVIDIA GPUs, but what does that alternative look like, and what is the scale of Gensyn right now?
Yeah, so to kind of talk about the vision, it's obvious to kind of everyone here that machine learning is basically the next industrial revolution. It's going to dramatically change the unit economics of everyone's jobs. It's going to free a lot of people from labor that they otherwise wouldn't want to do. It's going to cause a lot of societal change. It'll be interesting to see how it plays out in the US elections this year, for example. But it's also got very large consequences for kind of the fabric of the internet itself. So right now we exist with an internet that's basically quite static. You have the client-server model. If you want content, you call a server. It's quite static, there's just text there, get back. We reckon in the next kind of 2 to 3 years, it's going to evolve to a much more dynamic model where instead of knowledge on the internet being stored in kind of static form, it's embedded into the neural weights of machine learning models. So if you call a server, it'll be a machine on the other side, a kind of machine intelligence, receiving your prompt and giving you back the best result. And that has very kind of stark consequences for lower down the stack, because if you control the machines which can produce those models which serve you your information, then suddenly you have control over all the information on the internet. And the last kind of 10 years has been quite instructive about what happens when large companies start to control the internet. So the long-term goal, what's at stake, is basically a new kind of internet of machine intelligence. When we think about where we fit in there, we provide two things. We provide the ability to train a machine learning model across any machine learning compatible device. And when I say that, I mean any device where it makes economic sense to train a machine learning model. You're not going to do it on a Casio calculator. You're not maybe not going to do it on some a smart fridge or something. But you might do it on an M3 MacBook, for example. If and only if there's a decentralized network you can attach it to where you can receive a yield for the kind of computational cycles of that device. That creates kind of 5 really hard research problems. So the first problem is, how do you verify the work's done without increasing the cost dramatically? The most trivial kind of approach to this is just do Bitcoin, brute force, proof of work, just replication. Makes it too expensive, nobody uses it. We have a solution which lowers the cost significantly, so the overhead is kind of very, very low double digits. The second question is, if you want to compare results between devices, how do you do it in a way which is reproducible? If we have a NVIDIA A100 GPU, and then there's another NVIDIA architecture, V100, and you want to compare the results between the two, the way that the tensor floats and the calculations of the tensor cores are performed actually results in very slightly different outputs. So if you want to do kind of cryptographic hashing, which is obviously the name of the game in decentralized protocols, can't do it. So we have to solve that problem. The third issue is more of a machine learning one. How do you optimally distribute, chunk, and decentralize a very large neural network across all the devices in the world? There's really interesting research out of DeepMind, like the DeLoco paper, other papers like Varuna, other papers like ALPA, which try and address this. And it's probably one of the most interesting research areas in machine learning right now. They say the fourth point's around how do you kind of build the blockchain component of this, particularly around data availability. There's lots of kind of storage considerations. Where do you store proofs? How do you minimize the overhead? No one's going to send around, a sort of terabyte size, model architecture with weights, to every single node of a network. How do you optimize that? I mean, the fifth and final point is how do you, basically connect those 4 pieces in a way which is game theoretically secure so that people don't get, robbed on the protocol and people don't cheat. So that's what we've been doing for 4 years. And right now we have an internal version of a network, and we're looking to launch the private version of a network to early adopters later this year.
That's awesome, and also such a really good way to think about the set of kind of open problems here. How much of this is, well, actually, so I have a couple of follow-ups. So the first one is, in terms of actually implementation versus kind of the openness of the problem itself, are you already done implementing these fixes and it's just more about testing this with this private testnet? Or is it that these are just kind of the ways that you have to address this thing, but it'll still be some work to actually make sure this can happen on the network itself?
Yeah, I think that's a great question. So we have a version of it internally. I was using it last night, to train a small model. The kind of 3 main areas that we're focusing on are, one, the overall system-wide game theoretic security. One of the, as everyone in here who's built or is building a crypto protocol can attest, security is really hard to prove kind of, before you do a proper mainnet launch. But then when you do a mainnet launch, it's kind of all out there. And so sort of slowly kind of opening it up and managing to test it's one of the big pieces. And that touches all those kind of components I spoke about. The second thing that we think quite strongly about is that kind of data availability piece. So anyone in here who's building kind of a data availability layer, I think there's definitely a rising demand from machine learning protocols for that sort of service. So far, we've had to build our own one internally because we haven't found one which, externally, which kind of makes sense for us. But it's something that we're...
And maybe just to dig in, which aspect of data availability is more important here? Just the fact that you want cheap storage, or is it the fact that, in the case of machine learning, bandwidth matters and you have egress and ingress considerations? What's important in this case for us to think about?
Yeah, there's basically 4 things which are important. So the first one's price. It just has to be, cheap. The second one is bandwidth. So it has to be of at least like some minimum specification given how much someone's willing to pay for a machine learning job on the network. The third piece, though, is the data doesn't need to be there permanently. It doesn't need to be perpetually stored. But it also can't be kind of, in the IPFS parlance, like unpinned by the person who originally uploaded it, because then that breaks our verification mechanism. So one of the issues we have is, like, if you look at something like Filecoin, the minimum kind of deal, I think they call them deals in Filecoin, that you have to have is like 180 days. But if you're someone on our network who's just wanting to like fine tune, Mistral 7B, you don't want to like store it for like half a year, right? You want to store it for less. And there's ways that people could build those systems on top of it in a way which, on top of like Filecoin, which make it easier, but we haven't seen one which is kind of plug and play for our purposes yet. And then the final one's just fault tolerance, around, erasure encoding or erasure coding, how do you basically ensure that, if one of the nodes falls off, that it doesn't break the whole system? Because some of these jobs can be very expensive, and if a data component falls over, that's not great. So that's the kind of second thing that we focused on quite a lot, just the kind of data availability piece. I'd say the third and final piece is actually just the decentralized model training itself. So it's our, we know from kind of speaking with a variety of folks in the kind of machine learning space, even at the more centralized companies like OpenAI, Google DeepMind, there's a push to, design architectures which can train across, lots of decentralized compute, or at least distributed compute in different data centers. But the local paper by DeepMind, which I mentioned earlier, is a kind of good example of that. We're basically at a point where, as the computational requirements to get, emergent intelligence increase and increase further, you basically need more and more transistors, like in one place. And it's getting to the point where you just physically can't fit them, like in a single data center. I don't necessarily think there's like a kind of cap to this. Like, the scaling laws haven't broken yet. And it's quite clear that, if someone could make intelligence an order of magnitude smarter, and it would, create more economic value for them, they're probably going to want to do it. So there needs to be a solution that basically activates this kind of, world-scale compute network. So yeah, I think to summarize, like, the three kind of core areas we're working on just now are the security piece, the idea around kind of, almost like communications, but also data availability. And then thirdly, the machine learning research around how to optimally shard, and split models across the network.
Awesome. I guess one thing that hasn't been maybe explicitly mentioned, which I assume is the case, is that it is a network where anybody else can contribute their GPUs or any resources to help kind of let you train. And the intention is that after you kind of work out all the kinks, that you open it up and anybody can join and provide the hardware. Is that correct? Yeah,
so one of our core principles is that the network should be decentralized and permissionless. I think there's a lot of reasons for this. I'll give you the kind of top three. The first one is, in the very near future, like this decade, we want to build the network to support this. We think that the vast majority of demand on Gensyn will be from machines. It won't be from like a machine learning researcher like my co-founder or like someone like me.
What do you mean by that?
So like artificial intelligence or a machine intelligence which exists in a permissionless substrate somewhere, so it could be on Ethereum, which is providing economic value, maybe to one of us or maybe to another machine, being paid for it somehow, probably in crypto, but wants to improve the quality of its service because its objective function is for it to, provide more value or to, to just maximize its, its wallet balance. And it needs to call a network in order to basically update its parameter state such that it can provide more value, or even expand its parameter state. It needs a permissionless network to do that. It needs a permissionless money. It needs permissionless networking, and it needs kind of permissionless like data storage. The compute piece is the bit which is missing, and that's why we're all in on building it. But we think the vast majority of compute is going to come from machines kind of retraining themselves. And, when we think about what that also, the knock-on effects of that, it needs to be permissionless. There can't be a human in the loop. So that's reason one. Reason two is I think there's just a kind of fundamental liberty around, like a liberty piece here. Like, I think what Satoshi did was kind of basically give people their money back in a way, give you the keys to your money back, which is good. It's very similar to like concepts around like negative versus positive liberty. It's negative liberty, it's like you own the keys, it's yours. No one else is giving it to you. It's very kind of like Lockean property rights from the 1600s. It's you transform it. You find the Bitcoin, it's yours. No one else is giving it to you. We're moving to a world where our organic neurons in our brain, they've always been ours, but now we're augmenting them with these artificial neurons. But unless someone does something, those artificial neurons aren't yours. They're owned by OpenAI, or they're owned by DeepMind, or they're owned by whoever is creating the brain-machine interface. I think that's like pretty negative. And one of the kind of solutions to that, although it's not a panacea, is to provide a permissionless, peer-to-peer network where if someone wants to train a model which does a certain thing for them and augments their own intelligence, they're able to do that and they have the means to do it in a way which doesn't have to be sanctioned by some higher power.
I mean, that's an awesome prediction if we're betting on more machine-to-machine inference or even training. You've already obviously hinted about just the fact that it needs to be decentralized is a great answer for why crypto needs to be involved here, because you have those economic sort of guarantees. But what other overlap do you see with crypto and AI here? And do you have any kind of bold predictions on where we see that space going?
Yeah, absolutely. I think of it in kind of like 3 layers. So at the kind of most core layer, you've got the compute layer. We do machine learning training, but you could also do inference, for example, and there are companies doing that. So that's the compute layer. And then the next layer is kind of, I would describe it as like the machine learning operations, so to speak. So that's stuff like, model attribution. If you train a model in your data, how much, of the parameter space is a function of the data you contributed, and how do you get paid for that? Also ideas around like, guardrailing, if you want, like how do you kind of make sure that models are orchestrated in a way which, conform with or are aligned with what you want. So there's a bunch of stuff there. There's also, I'd say, like some of the data stuff fits in there as well. And then I think there's lots of people building at that layer right now. So like when we go to hackathons, we see lots of people like building in there. Then the next one, which I reckon is like maybe 3 or 4 years out, is once these 2 bits exist in kind of anger, and then there's there basically is something which would approximate artificial general intelligence, and it's permissionless, and it's on a cryptographic substrate.
And you're predicting this in the next 4 years? Is that what I'm hearing?
Yeah, I'd say so for sure. Right. Yeah. The next layer is how do they interface with the real world, and what's the kind of mechanism by which, like very like trivially, if a machine intelligence wants to mail something to someone, how do they like physically make the post office do it? It's like a pretty like dumb example, but like yeah.
Use the FedEx API somehow.
Yeah, yeah, exactly. But when like a person in like the real world has to actually do something, what's the kind of mechanism for that happening? I think there'll definitely be kind of Web 2 companies which are doing that. But I think it's something which is because I think a lot of the intelligence or most of intelligence will exist in Web 3 or crypto. I think it's quite kind of appropriate that there's those mechanisms in the cryptographic space as well.
Awesome. You said the private kind of testing is in the works. When can we see a broader public access to Gensyn, and kind of what's next for the protocol?
Yeah, so we don't like to kind of overcommit and underdeliver. It's the kind of name of the game for crypto protocols. But we're doing the kind of private testing this year, and then we hope to do the public testing probably next year, although it's kind of TBD. I think when we think about like what's next, we're very interested in kind of 2 areas. So anyone who's kind of thinking sort of deeply about the optimal ways to kind of train models across lots of decentralized devices, that's something we think very deeply about and would love to talk more about. But also anyone who's kind of providing any of those like ancillary tooling that we spoke about. Like I think particularly the data stuff, we weirdly we're like a compute protocol. Like we don't think about data.
Yeah, like you should be using something else.
Yeah, we should be using something else, right? And like it's something my co-founder and I have always kind of like we've kind of like grudgingly like built this thing internally, but you know, we've only built it because there hasn't been a kind of external solution that's become apparent. So anything in those two areas is something we definitely love to chat about.
Awesome. Well, Harry, thank you so much for this amazing conversation, and can't wait to have a better than AWS services out there that's decentralized.
Yeah, my pleasure. Cheers.
Awesome.